Hello everyone, I am Matteo Tafuro and this is my colleague Andrea Lombardo, and in this presentation we'll summarize the results of our reproducibility study which we conducted within the scope of the Machine Learning Reproducibility Challenge 2021. The challenge was born to encourage the publishing and sharing of scientific results that are reliable and reproducible. In support of this, the objective is to select a paper and verify its empirical results by reproducing the computational experiments. Our paper of choice was Exacerbating Algorithmic Bias Through Fairness Attacks by Merabi et al., which proposes two families of poisoning attacks that target the fairness of a classification model. The attacks are performed by injecting malicious points into the model's training set and are defined as influence attack on fairness, which is a type of attack that can harm both accuracy and fairness simultaneously to an extent that is controlled by the hyperparameter lambda, and the anchoring attack, which focuses on fairness. We aim to validate the 5 main claims of the paper, which can be roughly divided into 3 groups. First, we investigate whether increasing the value of lambda actually results in stronger attacks against fairness. Next, we compare the influence attack on fairness against the given baselines. And here, the paper claims that the proposed method outperforms both baselines on all tested data sets integrating fairness. And finally, a similar comparative study is conducted to prove whether the second type of attack, the anchoring attack, also outperforms the baselines. We compare the attacks to 2 methods from the literature, namely the one by Ko et al. And the attack introduced by Solans et al. And we test their effectiveness on 3 different data sets, namely the German, the Compass, and the drug consumption data sets. Our experimental setup is slightly different than the original papers due to missing details in both the description of the models and the provided code base. As a consequence, it's important to mention that the reproducibility assessment is specific to our own setup. Finally, the attacks are evaluated in terms of fairness using 2 different metrics, the statistical parity difference, SPD, and the equality of opportunity difference, EOD.
We will now go through the results of reproducing the 3 groups of claims. Under our setting, we confirm that larger values of lambda result in stronger attacks against fairness. The graph shows that as the test error lowers, more emphasis of the attack is put on fairness, which gets negatively affected for both metrics. The same findings appear in the other datasets. So we are able to reproduce the claim. The second group refers to the influence attack on fairness and the comparison with the 2 baselines, claiming that the proposed attack outperforms the baselines in affecting both fairness metrics on all 3 datasets. Under our setting, we are able to reproduce the claim for the first baseline, but not for the second one. Lastly, the third group refers to the family of anchoring attacks, claiming that it outperforms both baselines in degrading the fairness metrics on all 3 datasets. Again, we are able to reproduce the claim for the first baseline, but not for the second one. We also investigate the effects of using fairness instead of accuracy as early stopping metric during training, assuming it will result in more efficient attacks. An analysis of the curves confirms that the maximum achievable fairness is much greater than the same measure at the point of minimal accuracy, and the same phenomenon is observed for any dataset attack combinations. The table shows that fairness undergoes a stronger degradation if it is used to interrupt the training process. So our study reveals that although the proposed methods represent valid novel attacks against the fairness of a model, they are not always superior to other methods in the literature. In general, better statistics would give us a clearer insight into the relative performance of the models. However, given the obtained findings, we observed that the reproducibility of the claims depends on the chosen stopping metric. In fact, our results assume that the original authors used accuracy, but we observed that our findings could differ if fairness was used instead. Moreover, despite the intuitive explanation of the proposed methods, the paper lacks important details that forced us to make many assumptions. We leave their validation to future work. To conclude, the reproduction of the study required many educated guesses, under which we obtained the results that support 3 out of 5 claims. Therefore, we find it not possible to reproduce the original results with the sole use of the paper, and it's difficult even in possession of the provided code base. With this, we reach the end of the presentation. Please feel free to contact us if you have any questions or doubts. Thank you so much for your attention.